Howdy, it's Coach Primo again. I'm going to start you off. This is the second part of SAS 5, a cool tool. We're talking about the time value of money in Unit 6 of Finance and AQR, Advanced Quantitative Reasoning. So the bell ringer says, which variable has the greatest effect on the present value of an investment? Now recall, the present value of an investment is how much do you have to invest now in order to have a certain amount in the future. Based on how long you're going to have the investment and what the interest rate that investment has and how many compounding periods there are. Now, which one of these variables, time, compounding periods per year, or interest rate, have the greatest effect on present value of an investment? I want you to think about that for a second. We had an example in the last lesson talking about how time could improve your the amount of money that you'll have, or the longer back in time you start investing, the sooner you'll have reached your goals, or the more money you'll have over the same period of time as if you invested later. And we talked about that. Compounding periods, we didn't go over too much, but we looked at the difference between annual, semi-annual, quarterly, monthly, weekly, and even daily compounding periods. And I think we found that the compounding periods didn't have that great of an effect. It did, but it was over the course of long periods of time. And the interest rate, however, we know that a single click on 1% in the interest rate going up can vastly improve or discount the amount of money you need to put in to the account if you begin at a certain period of time, hoping to have a certain amount of money in the future. Higher the interest rate, bigger the discount. And that's what it's called in the financial world. It's called discounting the present value. Discounting the amount of money you have to put in to reach a certain financial goal in the future. All right, so let's move on. Great things. I've got a phone call today from Coach Izar, and while I didn't become the head tennis coach, I did retain my assistant tennis coach position, and I'm looking forward to next year and getting out on the courts and helping these kids learn how to play the game better. And all those returning kids, look forward to seeing y'all. And anyway, that's my great thing. Please be sure to share the great things that are happening in your life. I'd love to announce some things for people. Let's move on. All right. So Vanessa, this is the same lady we were talking about, this financial consultant. She has another client, Ronnie, who wants to save for retirement. He believes that he'll need $2 million since he's planning to be retired for 20 to 30 years. Now, he can save in investments that have the following parameters. The number of years to save is from 20 to 40 years. The number of compounding periods are annually, quarterly, monthly, weekly, and daily. And the interest rate can be between 2.77% and 5.23%, or any rate in between. So we're going to look and we're going to divide this up into 5 different sections, 5 different types of years, 5 different compounding periods, and then 5 different percentage rates. Okay, so let's check it out. We're going to do this. Ronnie wants to know the effect that each variable has on the present value of his investment. So we're going to select a variable and use the following steps to complete each table. 1, start with the minimum value of each variable. 2, use the average value of the other variables that have parameters. And then 3, calculate the present value of the investment. And 4, decide the next value of your variable to test and repeat the process for a total of 5 different values. So we're looking at years first. And the number of years are variable. It varies from 20 to 40. So we put in 20, 25, 30, 35, and 40 years. Minimum number of years he's going to put in his investment is 20. Let's see what that does to his present value. So he wants $2 million, and he's going to divide by 1 plus, and we're going to take the average of the percentage, which is 4%, 0.04 divided by 12, which is monthly. We're taking the average of the compounding periods, which is monthly. If he only wants to wait 20 years, and he's going to have to put $899,854. Okay, in 25 years, we do the same exact situation. The only thing that changes is this exponent right here. Okay, 12 times 25, we have the discount is about $160,000. So if he wants to just save for 25 years, it'll still cost him almost $750,000. Well, how about 30 years? $603,591. It's going down quickly. How about this one? Less than $500,000 to make $2 million. That's pretty cool. That's pretty cool. And then in 40 years, Ronnie only has to put in $404,868.86 to have $2 million in 40 years. So let's look at the percentage of the change in present value. 20 years, minus 18%. Okay? Between 25 and 30 years, it's a change of minus 18%. Between 30 and 35 is a change of minus 18%. And finally, 35 to 40 years is minus 18%. How about if we look at compounding periods? So that's annual, quarterly, monthly, weekly, and daily. So if we do it annually, and notice that 20 is the average and 0.04 is actually what? It's the interest rate. That's right. Okay. So it's only one time a year we take interest rates. So only have 30 compounding through the life of the investment. Okay. On quarterly, it's $605,989. Monthly, $603. Weekly, $602. And daily, $602,428. It's only saving about $200 between weekly and daily. Now let's look at we want to compare apples to apples, not apples to oranges. So we want to make sure we're looking at the change in present value in percentages. In this one, we only have a difference in percentage change of minus 1.7% from annual to quarterly. From quarterly to monthly, we have less than 0.5% change. The discount only went down less than 0.5%. From monthly to weekly, it went down 0.2%. And from weekly to daily, the change was negligible. Not even, it's only 0.4 It hasn't changed at all. So that really is not an effective way to raise your money. How about the interest rate? So we go from a minimum of 2.77 to a maximum of 5.23. Let's look at the present value and how that is affected by the change in the variable. Notice that we're going with monthly. That's what the 12 is there. 30 is the average of the number of years that each investment is held. 12 is the average monthly number of compounding periods that each investment holds. So if we go with 2.77%, we only have to invest $872,061.63. If we go up a little bit in percentages to 3.385%, our investment only cost us $725,478.94. The average 4% between the minimum and maximum values allows us to only have to put in $603,591.73 as a present value. And as you can see, it goes down. But we want to compare apples to apples again, so we're going to look at the percentage change in present value. From 2.77 to 3.385, we have a negative 16.809%. From 3.385 to 4%, a negative 16.8009%. From 4 to 4.65%, a negative 16.793%. And then from 4.615 to 5.23, minus 16.785%. So we're still getting a pretty big discount on our investment if we initially invest with a higher interest rate. So overall, what impact on the present value does each variable have? Number of years. Changing the number of years in increments of 5 appears to have a steady rate of decrease on the present value, or a discount rate of 18%. How about number of compounding periods? Allowing the number of compounding periods to vary from annual, quarterly, monthly, weekly, or daily has a very small effect on the changing the present value. Overall, what impact on the present value does each variable have? Again, interest rate, massive changes, 16.8% down, but it's still not as much as the time. If you change time, that changes a lot of things. So of all the variables, which seems to have the greatest effect on lowering present value, if we base our answer solely on the greatest level of reduction of present value or the greatest discount rate, then the number of years has the greatest effect. However, the amount of change in each variable could have a drastic effect on this answer. Now I'm going to launch you. It's a really quick lesson. You'll have an assignment. Now, I like these memes. One does not simply not care about interest rate. Some people make all their money by investing their money somewhere and just living off the interest. 6.8% interest on my student loans will ruin my finances. No, it won't. Borrowing to cover a $30,000 a year in tuition is going to make you have a problem. You don't have to borrow that money. There's all kinds of other options you can do. And one of the options I like to tell everybody is to make sure that they pursue the trades, because the trades don't cost anything to get trained unless you want to go take training. You could actually go work for a company, and they have a training plan in there for you, and you get your journeyman after a while, and next thing you know, you're running your own business. So anyway, that's it. Get those questions done. I appreciate you checking out my... Okay, that's it. Let's make sure that we get those questions done on this Ed puzzle, and I'll see you guys later. Be blessed. Be a blessing.